I didn't learn Bayes' theorem in a statistics class and then go looking for a use for it. I ran into the problem it solves first. And see a number move on a dashboard, feel a jolt of something's wrong or something's working, and act on that feeling before I'd even asked whether the number was actually telling me what I thought it was telling me. That gap between a number moving and the number meaning something is where this whole idea lives. I run a few small businesses of dashboards exactly like that. Proxies, phones, content sites, and every one of them throws numbers at me every single day. Churn ticks up, a test result comes in, a chart spikes overnight. None of this is abstract to me. The mistakes I'm describing in this video are ones I've made with my own money, on my own dashboards, not ones I picked up out of a textbook and am reciting back to you. Bayes' theorem sounds like something out of a 300-year-old math paper, and it is, but the idea behind it is something you already do informally, all the time. If a friend who's never late tells you they're running late, you believe them and start worrying. If a friend who's always late tells you the exact same thing, you shrug and keep working. Same words, same evidence, completely different reaction, because you walked in with a different prior belief about each person's. That's Bayes' theorem, already running quietly in your head, with no formula in sight, and no math homework required. The theorem is just a formal way of doing that on purpose, with numbers, instead of by gut feel. It's a way of updating what you believe when new evidence shows up. The formula itself looks intimidating on a page. The idea underneath it really isn't. It says your belief after seeing evidence should depend on three things. What you believed before you saw it, that's your starting point. How likely that evidence is if your belief is actually true. And how likely that evidence is overall, including in the case where your belief turns out to be false. Skip any one of those three pieces and you can talk yourself into a conclusion the data never actually supported, and you sound confident while you do it. For a founder, this shows up constantly, usually with no warning. A metric spikes on a Tuesday for no reason you can name. A test you're running suddenly shows a winner. A customer's usage graph looks like they're about to walk out the door. The real question in every one of those moments is never whether the number moved. It's whether the number moving actually changes what you should believe, and by how much it should change it, which is a much harder question than it sounds, and one most people never actually stop to ask. Start with what you believed before you saw the new evidence, based on everything you already know about your own business. That's your prior. If you've run your product for 2 years and your monthly churn has sat in a narrow band the whole time, say between 3 and 5%, that history is your prior. It doesn't mean next month can't be different. It means different needs real evidence behind it, not just one bad-looking week that scared you into a decision. Next is the likelihood. How likely the new evidence is if your belief is true, compared to how likely that exact same evidence would be even if your belief is false. A test result that the genuine winner would produce 95% of the time, but that the plain coin flip would also produce 40% of the time, isn't nearly as convincing as it first sounds, even though 95% sounds like a strong number on its own. Put those two things together and you get your posterior, your updated belief after combining the prior with the likelihood. It isn't the data proved it, it's given what I already knew, plus what I just saw, here's where I land now, and here's how confident I actually am in that new position. That confidence part matters. A posterior isn't a light switch, on or off, it's a dial. The mistake most solo operators make, and I've made it plenty of times myself, is skipping straight from the evidence to the conclusion and never bringing the prior into it at all. You see one good week and you treat it as proof the business turned the corner, when your own history should have told you that one good week happens periodically even when nothing about the underlying business actually changed. Here's a worked example, the kind of thing I actually deal with. Say you build or buy a tool that flags customers as high risk of churning based on some drop-off in their usage. Suppose the tool is genuinely decent, not perfect, just decent. It correctly flags 80% of the customers who actually go on to churn, and it only misfires on 10% of the customers who were never going to churn in the first place. Direns breitopitemers en taandimein. 80% catch rate, 10% false alarm rate. Most people would call that a solid tool and move on. But whether a flag customer is actually likely to churn depends heavily on how common churn is in the first place, and that's exactly the piece a raw accuracy number leaves out of the picture entirely. Let's say your monthly churn rate is 5%. Out of 1,000 customers, 50 are true churn risks and 950 are not. The tool correctly flags about 40 of those 50 real risks. That's the 80% doing its job. But it also misfires on 10% of the 950 who were actually fine, and 10% of 950 is 95 people. So your flagged list ends up with roughly 40 real risks and 95 false alarms sitting side by side, about 135 names total. Even with a genuinely useful tool, most of the people on that flagged list were never actually at risk of leaving. This is the same math behind why rare disease screening tests throw off a lot of false alarms even when the test itself is quite accurate. And doctors run into this exact same trap constantly. The lesson here isn't stop using churn flags. The tool is still doing real work and still worth having. It's don't treat flagged as confirmed. Use the flag to decide who's worth a closer look and a personal check-in, not who to panic about or discount immediately. The rarer the thing you're trying to detect, the more false alarms a good detector still produces, purely from how rare it is to begin with, no matter how well built the detector is. That's Bayes' theorem doing its job quietly in the background, and it's a specific, learnable reason to distrust your first gut reaction to an alert. Now take the opposite situation, a result that looks like a clear win instead of a scary alert. You try two versions of a sign-up page. Version B converts better over the test period, better by a few points. It's tempting to call a winner right there, ship it, and move on to the next thing on your list. Before you do, ask what your prior actually was walking in. If your two versions are nearly identical, say a headline reworded slightly with the same offer underneath, your prior should be that they probably convert at close to the same rate because most small wording changes just don't move conversion much on their own. A modest difference over a small number of visitors is exactly what you'd expect to see from ordinary noise. Even if the two pages perform identically underneath, the evidence needs to be strong enough to overcome that skeptical prior before you should update your belief by much at all. If instead your test is something with a much bigger, more plausible effect behind it, removing a paywall step entirely, say, or cutting your sign-up form from 6 fields down to 2, your prior allows for a much bigger real difference between the versions. So that same size of evidence becomes a lot more convincing, because a big effect was plausible going in. That's why one by a little on a small sample on a subtle wording change and one by a lot on a decent sample on a structural change to the page deserve very different amounts of trust, even if both technically show version finishing ahead. Bayes' theorem is the formal reason those two situations aren't equally believable, even though a simple before and after chart would make them look the same on the surface. I've personally killed tests I was genuinely excited about the moment I sat down and asked myself honestly what my prior should have been going in, and it stung a little every time, but it beat shipping a change that was never really doing anything. Once you start thinking this way, a few habits follow pretty naturally, and they're not complicated once they click. You stop treating single data points as verdicts. A metric that's genuinely new information, a launch, a pricing change, a channel you've never tried before deserves more weight than one ordinary week of variation in a metric you've been watching for years. New information earns more trust than routine noise does. You start asking how rare the thing you're trying to detect actually is before you trust an alert about it. Rare events produce more false positives, and intuition suggests, no matter how good the detection method behind them happens to be, whether that's a churn flag, a fraud check, or a broken tracking alert, you size your confidence to your sample. A result from 40 visitors and a result from 4,000 visitors are not the same kind of evidence, even if the percentage lift looks completely identical on paper. Small samples swing around a lot for no real reason at all, and you keep updating instead of anchoring on one snapshot forever. Your posterior belief after 1 week becomes your prior going into the next week, and the week after that builds on top of it again. Bayesian thinking isn't a one-time calculation you do once and file away. It's a habit of continually folding new evidence into what you already knew, instead of resetting your beliefs from scratch every single time a new number shows up on the screen. It's worth being honest about what this doesn't do for you too, because it isn't magic. It's not a substitute for judgment, and it won't tell you what your prior should be. That part is still on you, built out of your own experience running your own specific business. It can't fix a bad measurement either. If your tracking is broken or your sample is biased in some way, updating your beliefs correctly on top of bad data still gets you a confidently wrong answer at the end of it. And it doesn't remove uncertainty from your business, it just helps you reason about that uncertainty more honestly, instead of overreacting to noise or underreacting to a real signal sitting right in front of you. None of this promises a particular result for your business, and it isn't financial or legal advice. It's a way of thinking more clearly about numbers you already have in front of you every day. Every one of these explainers lives in writing at dataresearchanalysiscollection.com, the whole metric library. In plain English, if you want to sit with the churn math or the sample size math a little longer than a video allows. Every metric explained in writing at dataresearchanalysiscollection.com. So go have a read when you get a chance, and if this was useful to you, go ahead and subscribe for more.